All right, we're going to cover 9.3 today. 9.3 is to reflect figures. Our objectives are reflecting figures, and in the 9.5 section we'll cover composition of transformations. Well, let's review a little bit some of 9.1 type problems. Okay, just to review here, we've got a translation where we're adding 6 to x and subtracting 3 from y. So this, to find the image of A, I would add 3 plus 6, it would become 9. It's 9, and we subtract 3 from 2, we get negative 1. That would be the image of A. So that would be A prime. Okay, let's do a pre-image. So we've got 2 and negative 7. Same translation, but this is we have to find the starting point, the pre-image. So what am I going to do to the 2 to find the pre-image? What do I do there? Yes?
Bigger than x.
What's that?
Oh, the pre-image.
Mm-hmm.
You add just 2 and 6, or you subtract it.
Yeah, you subtract it. You do the opposite. If we have to find the pre-image, this is the result of doing this. So to get back to the original, we do the opposite sign. We subtract 6. So the pre-image of this would be 6 minus 2. 2 minus 6, which is negative 4. And what would the y value be? Negative 7 minus 3. What's that?
22 plus 3.
Oh, yeah. You're right. It would be plus 3 because we're doing the opposite. So it would be, yeah, negative 4. You're right. You were right. Okay. All right. So we've got those examples, and we've got these. It's the same idea, except you plot the triangle, and you move it, each one of its points, according to this translation. Anybody need to review that? All right, and then we've got. This is asking you what the translation was. You just count points. Like on 7, you're going from A to A prime, so you go left 1, 2, 3, 4, 5. So that's going to be x minus 5, and then you go up 3. That's y plus 3. And then you've got your component form, vector component form here. So it's the same idea. From this point to where the arrow is, where your ending point is. Okay, we are going right 5, so I make a bracket. First value is 5, I go up 2. Second value is 2. Any questions on that? All right, good. Let's go ahead and get started on 9.3 then. We're going to do reflections with 9.3. So 9.3, a reflection, is a transformation that uses a line like a mirror to reflect an image. It's a mirror image across the line. So we have a line of reflection is a line that acts like the mirror to reflect an image. Now, just up front, I'll just tell you, okay, so if our line, say we have this this shape here on this side right here, right? If I reflect across this line, it's you can see that it's the mirror of that, the flip of that. Okay, that's pretty straightforward. Where it gets tricky is when you have the object, part of it is on both sides of the line, right? So if we had an image like, if we had, let's say we had a triangle that's on both sides of your line, right? When you reflect that, we'll do it in a different color. When we reflect that, part of the triangle will be on the other side of the line, and the part of it will be on the same side. It's on both sides of your line of reflection. That's where it gets tricky. All right. So we have the vertices A, B, C. So we have A is the point 1, 3. Let's plot that. So there's 1, 3. That's A. Then we have B is 5, 2. And C is 2, 1. Now, if you have either a vertical or horizontal line of reflection, okay, so y equals 1, is that vertical or is that horizontal line? Y equals 1. Yeah, it's horizontal. For every y is up 1, right? So for any y, any x, we're going up 1. So that's a horizontal line. You have to have that straight. Y lines are horizontal. X equals the number is vertical. So this is a horizontal line. So there's my line of reflection. Okay? And if we're going to reflect across that line, if it's for this horizontal line, if the point is on the line, it's going to stay there. All right, we'll do that in blue. It stays. So this is going to also be C prime. For your other points, you just count, right? If A is 2 from this line this way, then it's going to be down 2 the other way. So A would be here. There's A prime. Let's move that C out of the way. Let's put the C. Put the C here. There's C prime. Right? And then B. B is up 1 from the line here, so it's going to be down 1. Right? So there we have B prime. Right? So the original triangle looked like this. The resultant triangle looks like that. It's reflected across that line. Now notice, I didn't just change the sign on my y value because the line was not y equals 0. Okay? It was y equals 1. So this new value for B is it's still 5 over, but it's 0. So it goes from 2 to 0. But you can do that by looking at the graph and seeing where the point is. Is the reflection clear? Any questions on that? Okay. Everybody have it? Moving on. Here's the solution. Looks like that. Very similar to what we had. Right? Okay. Graph a line, a reflection of ABC from example 1 in the given line. Y equals 4. All right. So, anyway, we have it's the same original triangle. Our line of reflection is here. So to graph the triangle, then again, you're counting points. The distance from the red line to A was 1. So we went up 1. This distance from the red line to C was 3, so we go up 3 from there. And the distance of B to the red line was 2, so we go up 2 from on the other side of the line. That gives us our new points. Everybody get the idea? All right. All right, so now they're asking you to reflect across the line x equals -3. Okay? We reflect across the line x equals -3. Is that a vertical or horizontal line? That's vertical. That line is, looks like this. There's your line of reflection, -3. We'll just use, we won't use the same figure. Well, we'll just make up some points of our own. So let's say our figure is this triangle. Okay, that's our original triangle. That's the pre-image. When we reflect across the line, so we'll call this A, B, C. When we reflect across the line, all right, then somebody tell me what the coordinates of A prime would be. What would the coordinates of A prime be? Right now they're -2, 1. Right.
-4, 1.
Yes, it'd be -4, 1. This would be A prime. Okay. What about C, Kayla?
It'd be -5, 4.
Good. -5, 4. She counted over 2 from the line. Okay. What about the last point, B? Where would it be? Trent?
-5, 1.
-5, 1. There's your image. All right. Everybody got it? Okay. And that's okay. Now, some rules. Some rules. You can refer to these when you do your homework. Eventually, you know, if it's across the x-axis, that's a x-axis is a horizontal line. So you can do the counting method. You don't necessarily need to memorize that it's A negative B, because you know that's what you were doing. Okay, but for those two, you know, and for across the y-axis, you change the sign on the A value. All right, those two, again, you can figure those out by looking at the graph and counting. Where it's difficult to count is when the reflection is at a diagonal. So if we have the line y equals x, which remember, if we have a coordinate plane, the line y equals x is a slope of 1, right? The coefficient of x is 1, so that's 1 up and 1 over is our slope. So it's this diagonal line. If we have that, if we reflect across that diagonal line, all right, what you're going to do is, this is the best to memorize this. You just switch the points. A and B flip positions. You don't change any signs. You just switch the order. It becomes BA. That's if you have a positive slope diagonal line. If you have the line y equals -x, which looks like, here's your coordinate plane, then the graph of that is this dotted line, right? If it's negative, then, okay, the rule for that is -b, -a. So you change the order and both the signs. The order and both the signs, all right? So these two, I mean, you can figure it out if you know, maybe you may kind of have to guess a little bit by just looking at it visually on a graph, but I would memorize these two right here for y equals x and y equals -x, so that I know without a doubt where those points are going to be. All right, so let's do some examples. Okay, reflecting across the x-axis. So the endpoints of f is negative 1, 2, and g is 4, negative 1. There's our line. We're reflecting over the x-axis. Which one is the x-axis? Vertical or horizontal? Yeah, it's the vertical. This is the, no, it's not the vertical, it's the horizontal. That's the x-axis, right? So that, and it's the x-axis, or you could say it's y equals 0. So it's kind of confusing, you know, they call it the x-axis, but it's the equation y equals 0, okay? So again, what I would do, if I were doing this problem, I would use the count method. If this is 2 up here, it's going to be 2 down here. There's my new point. This is F, this is G, so this becomes F prime, and this point becomes 1 up, it's G prime. Right? So the coordinates of the new point, as you can see, still negative 1 for F, but it's negative 2 now. G prime, 4 over, and it was negative 1, so now it's positive 1. You switch the sign on the second number. Questions? Everybody got it? Okay. Now we're going to do it across the y-axis. All right, so we have the point negative 1, 2. There's F. And G is 4, negative 1. Come on, G. 4, negative 1. There's our line. Okay, the y-axis is the line x equals 0. So it's going to be this line. Okay, so this was this F point was at negative 1, 2, and the G we've got. Okay, so somebody tell me the coordinates of F prime. F prime is going to be what? Reflecting across the red line. What would the coordinates of F prime be? Braden, what do you think?
Negative 1, negative 2.
You're reflecting across this line.
Oh, my bad.
You want to reflect across the vertical line. Ellen?
2.
What?
1, 2.
1, 2, yes. 1, 2. 1 over. 2 up. I just count. If I start with this point, it's 1 from the line, so I'm going to go 1 from line here. Somebody do this point. What's its coordinates going to be? Bobby.
Negative 4, negative 1.
Yes, negative 4, 1. Negative 1. It's 4 over here, so I go 4 over this direction. Negative 4, negative 4, negative 1. So G prime, negative 4, negative 1. I've reflected across the y-axis. Any questions there? No questions. Okay, very good. All right. Now, see if you remember. We had the line. We're reflecting across the line y equals x. That's the diagonal that slopes upward. Right? There's our diagonal. Y equals x. All right, we have F. F is at negative 1, 2. And G is at 4, negative 1. Right? So there's our line. Okay? We're going to reflect it across y equals x. What would be the coordinates of the point F prime? What would the coordinates be? What are we doing? What's our rule? It's in your notes. What's the rule when you're reflecting across y equals x?
Switch B and A.
Yeah, you just switch it. So it becomes the point, our new point is the point 2, negative 1. 2 over, negative 1 down. There's our new point. That's f prime. 2 over, negative 1 down. That's f prime. Right? And G becomes what? What does G become? Tiffany, what's G become?
Negative 4 1.
No, you're not changing the sign.
Negative 1 4.
Right, negative 1, 4. So it's negative 1, 4 up. So that's going to be up here. Right in the middle of where I labeled the other point. Let's see if we can draw it here. Come on, there it is. Okay. So that's going to be G prime, and it's negative 1, 4. So you draw it. Okay. So after you draw that line, you can see it's kind of like a mirror reflection here across that line. Everybody got it? All right. Let's do y equals negative x. So that's a diagonal line slanting downward, downhill, going left to right. It's going downhill.
Where are we drawing these at?
You don't have place in your notes for these?
The points aren't the same as on the screen.
What's that?
Like the points that are in the notes aren't the same as the ones on the screen.
They aren't? Yeah.
That makes a triangle.
You guys want to use is it y equals negative x?
Yeah.
What are your points? We'll do your points. Give me one of them. Give me a letter and the numbers.
A1.
A 1 over 3 up.
Yep.
1 over 3 up. That's A. 1, 3. Okay? Give me another one.
B4, 4.
B is 4, 4. There's B. 4, 4. Okay? Give me another one.
C, 3, 1.
B.
C.
C. 3, 1. C. 3, 1. All right. So we have this triangle we have to reflect. All right? So, somebody tell me, what would the coordinates of A prime be? Coordinates of A prime. Yes.
Negative 3, negative 1.
Yes. You switch the order, change both signs. So it becomes, as you said, negative 3 over negative 1 down. Let's do it in a different color. Use blue here. So that's going to be, that's A prime. A prime is negative 3, negative 1. Somebody tell me what B would be. Kenzie, what do you think? What do you think B would be? Kayla?
Negative 4, negative 4.
Right. We switch the order, but it's the same value, so it doesn't really matter. But they both become negative. So it's negative 4, negative 4. That's B. Negative 4, negative 4. And then C. Okay. C is, Allie, what's C going to be?
Negative 1, negative 3.
Negative 1, negative 3. There's C prime. Negative 1, negative 3. We draw the triangle. All right. It's a reflection. Any questions on that? Okay. Let's see. These were the values you guys just gave me, weren't they? Okay, we'll skip that. Okay, now we're going to do a composition of transformations. So the composition, a glide reflection is a translation and a reflection. Okay, it's a combination. So you do it in the order that it, if it gives you an order to do it in, make sure you do it in that order. But if it doesn't say, you'll translate first, then you'll reflect. So a glide reflection is a transformation in which every point P is mapped to a point P prime by the following steps. A translation maps P to P prime. A reflection in a line K parallel to the direction of the translation maps P prime to P double prime. You don't want to wait till the end of the notes. We're about done. If you can wait, if it's all right. A reflection in a line K parallel to the direction of the translation maps P to P double prime. So it's basically saying it's a translation followed by a reflection. So we're going to do this example. The vertices of A, B, C, let's plot the points. Do you have this one in your notes? All right, so the vertices of A, B, C are A, 3 over 2 up, B, 6, 3, and C is 7 over, which doesn't even fit on the graph, and 1 up. Okay, there's 7, 1. That's C, 7, 1. So it's this triangle, right? And find the image after the glide reflection. Okay, so it gives you the translation first. Yes?
It's negative 12. It's negative 12, x minus 12.
Let's do 6 so it fits on the graph. So change it to 6 in your notes. X minus 6. All right. So, what is going to change, the x or the y, according to this translation? X, right. Now, it may be both. It could be both, but in this case, they're just changing the x. So we're going to subtract 6 from all our x values. So A becomes 3 minus 6 is negative 3, so it becomes negative 3. Let's do this in a different color. So we've got A prime is negative 3, 2. B is 0, 3. And then we subtract, for C, we subtract 7 minus 6 is 1. It'd be 1, 1. These are my prime values. So this is C prime. It's 1, 1. So we've slid that triangle over. Now we're going to reflect it with respect to the x-axis. Which one is the x-axis? The horizontal. Good. We're going to reflect it across this line right here. Right? So when we do that, reflect it across that line. Somebody give me the coordinate for C double prime. What would it be? C double prime, what would it be? Coordinates.
1, negative 1.
Right, you're changing the sign on the y values, right? It becomes, you just count what's 1 up, you go 1 down, so it becomes come on, right. C becomes 1, C double prime is 1, negative 1. Okay? What would B double prime be, Levi?
I'm not sure.
Okay? Erica, what would B double prime be? Yeah, 0, negative 3. Good. So B double prime is 0, negative 3. And then we've got A double prime. Erica, I already just called on you, didn't I? Megan, what would it be? What's that? Kayla?
-3, -2.
Yeah, -3, -2. You just, Megan, you've got your 2 up here, so you're going to go 2 down here. So it becomes -3, -2, and that's going to be a double prime. So when you draw it, it should look like a mirror reflection. All right, any questions on the glide reflection? Everybody has it, okay? There's a solution. Now, we're not. That's it. We're done.